This time we're looking at recording and modeling with variations or modeling using variation. A couple pointers to notice. One is if it states that one property varies directly to this another property, as I stated in my note 1, y varies directly to x or y is directly proportional to x. How do we translate that equation? The translation of that equation is y is equal to some multiple of x, kx. Okay, we refer to k as some unknown multiple here. So y equals k times x, where k is just some number. We don't know what that is, but that's what we're looking at. And then the second scenario is the inversely proportional, or varies inversely to the other object. So y varies inversely to as x, or y is inversely proportional to x. What does that mean? That translates to y equals k over x. So once again, inversely brings in the 1 over x, and since it's proportional, you still have to worry about that multiple k. So once again, if it says directly proportional, we say, oh, it's equals to x, not exactly, there's some multiple k. And if it says it's inversely proportional, same way, we go, well, not exactly equal to 1 over x, but instead some multiple of that, okay, which is the same thing as k over x. So let's look at the first one. In the first example, you have y varies directly as x, or directly to x, either way is the same thing, which tells you that the relationship between y and x could be translated as y equals k times x. Since it's directly, not inversely, it's equals kx. Alright, y equals 15 when x equals 3. Okay, well, y equals 15, so the left-hand side would be 15. And k we don't know, but we do know at that time x is 3. Can we solve for k here? Can we find that model? Well, k is the only unknown on the right-hand side. To solve for k, we would divide both sides by 3. So 15 over 3 results in 5 equals k. So if we look at our equation again, we're looking at something as y equals 5x. That's the relationship. So y is 5 times x. So you're asked to find y when x equals 9. So this time you know what x is, you're looking for y. So the left-hand side stays as is. Right-hand side becomes 5 times 9. So all we're doing is substituting what we have. What is 5 times 9? 45. So when x equals 9, your y equals 45. That's all. So the key part is translating into that equation, into an equation of this form. Okay? That's the work. Other than that, it's a lot of algebra. Algebra that you have worked with before, nothing severe, nothing like the previous section, that whole solving rational equations in a little more clumsier way than the type of equations we have here. Okay, let's look at the next one. Y varies directly as x, okay, and inversely to z squared. So if I just look at that first part, y equals, not really x, I have some sort of a k there, and inversely to z squared, that means also 1, so you have some sort of 1 over z squared in here. Now the question would be, well, do I need to bring another k in here? No, you have that 1k sitting right there. So basically you can imagine the 2 k's, one coming from x and the other one coming from z, put together as a single k. It doesn't matter whether you have 2 or 1, but when you have 2, it becomes harder to solve for the k. So we imagine it as the 2 k's multiplied together to give you this k that I highlighted. So if I clean this out further, this looks like kx over z squared. So y equals kx over z squared. Okay, so in this case, it says y equals 14 when x equals 7 and z equals 3. So let's plug that in. Remember that you'll always be given something like this to solve for the unknown k. Okay, so the left-hand side becomes 14. The right-hand side becomes k times x, which is 7 over z squared, which is 3 squared. Well, that's the same thing as 14 equals 7k over 9. How do I solve for k? Well, remember, k is being multiplied by 7 9, so I can get rid of 7 9s by multiplying by its reciprocal. Or you can think of doing it in two pieces, which would be times by 9 first and then divide by 7, or vice versa. So I'm going to go with multiplication by reciprocal in this case. When I do that, well, on the right-hand side, the 9's cancel out, the 7's cancel out. I'm down to an equation that looks something like k on the right-hand side, but what's the left-hand side? Left-hand side, well, 7 goes into 14 twice, leaving you with 9 times 2, hence the answer of 18. So if I look at my equation, which was y equals kx over z squared, will now be 18x over z squared. So that's my equation. The question is, find y when x equals 21 and z equals 6. So how do I do that? Well, plug in the information I have. So y is what I'm looking for, so y stays as y. 18x, I know that's 21, so 18 times 21, over z squared. Z is 6 squared. So that's the same thing as 18 times 21 over 36. Simplify that further. If you recall, 18 goes into 36 twice. So what do you get? Y equals 21 over 2. If you want to write it as 10.5, sure. If you don't, that's the same thing. The two are exact solutions, so you don't really need to do anything else. That's all there is. Let's look at a word problem. Says the distance at which a spring will stretch varies directly as the force applied to the spring. So we're talking about the spring. Let's say I go with the stretch of the spring. So let's say I use S to denote stretch and F to denote the force. Okay, so the distance at which the spring will stretch, so I'm talking about I'm referring to that whole distance as the amount of stretch with the S. Okay, if you want to call it D for distance, doesn't make any difference. So let's say the amount of stretch S is, it says directly, which will stretch, varies directly as the force applied. So the force is proportional directly to x, the stretch. So S equals KF. Okay, stretch is directly proportional to force, vice versa. Same idea there. Okay, so a force of 2 pounds is needed to stretch a spring 9 inches. So you're given the force, it shouldn't be well, it should be 12 pounds. That'll make it a nicer problem to work with. So a force of 12 pounds is needed to stretch a spring 9 inches. So my stretch, we said, is 9 equals K times force, which I changed to 12. How do I solve for K? Well, divide both sides by 12, right? So that gives me K on the right-hand side, 9 over 12, which I can further reduce to 3/4. So now my equation looks like S equals K, which we said is 3/4 F. Alright, so the question is, what force is required to stretch the spring directly 15 inches? So I know that I want the stretch to be 15. What I'm looking for is the force, the F in this case. So the left-hand side, which is the stretch, would be 15 equals 3/4 F. How do you solve for F? Well, we got to get rid of the 3/4, right? We want to isolate F. So to get rid of the 3/4, you multiply by its reciprocal, which is 4/3. Alright, that cancels out wonderfully. We're down to force equals 15 times 4, which is 60 over 3. What's 60 over 3? That is 20. Good. Okay, so in other words, to answer this question, which was what force is required to stretch the spring directly 15 inches, it would require 20. What would be your units? Pounds. 20 pounds of force is required to stretch the spring directly 15 inches. That would be the answer to this problem. Okay, so be sure to write that interpretation down. Let's look at the next one. In the next one, it says the water temperature of the Pacific Ocean varies inversely to water's depth. Okay, let's write that down. So let's say T is for temperature and D is for depth. So once again, it says the water temperature of the Pacific Ocean varies inversely as the water's depth. So, whoops, let's get rid of that. So T equals inversely to water's depth, which means 1 over D, but remember you have to bring in that multiple. So we'll change that one to 1 times K being just the K. So K over D. If you remember it as equation K over D, just do it that way, however you can remember that. But remember, you have to know these for the final. You can't have any notes on you for this final, so know these equations now, and so that you don't have to worry about it later. So the water temperature, it says at the depth of 1,000 meters, the water temperature is 4.4 degrees Celsius. So, do I know my left-hand side? Yeah, the left-hand side is 4.4 K over the depth, which I'm given as 1,000 meters. Okay, so let's solve for K. How do you solve for K? You multiply both sides by 1,000, right? So what is that equals to? That is 4,400. So your equation now looks like T equals 4,400 over D. So T equals 4,400 over D. The question is, what is the water temperature at the depth of 5,000 meters? So you are to find the temperature when the depth is 5,000 meters. Okay, so T is equal to 4,400 divided by 5,000. There we go. The zeros cancel. 44 over 50. They simplify further down to approximately 0.88. So what would be the answer to the question, which is what is the temperature of the water at the depth of 5,000 meters? The temperature is 0.88 degrees Celsius at the depth of 5,000 meters. That's all there is in section. So in this particular section, so you mainly have to know this one note that I wrote down, the two parts. If it's directly proportional, then y equals kx. If it is inversely proportional, y equals k over x. And everything else depends on that. You'll be always first writing your model, then solving for k. Once you have the k, you'll be asked to use that new equation that you found with the value of k to solve for one of the unknowns. It doesn't matter which unknown, but you should be able to do one of the unknowns given. But that's all there is in this particular section.